You all know what this is. This is a Formula One car, capable of reaching speeds of up to 375 kilometers per hour. But have you ever wondered how this small V6 hybrid engine produces nearly 1,000 horsepower? And what changes are made in 2026 that marks the start of a new era for F1 engines? Since 2014, F1 cars have used a hybrid V6 engine, small in size but extremely complex in design. The F1 power unit is actually made up of two main parts, the V6 turbo engine and the hybrid electric system. F1 cars use a V-shaped, 6-cylinder, 4-stroke engine with a 90-degree V angle. You all know how a 4-stroke engine works, right? Intake, compression, power, and exhaust. Simple. Now, after the power stroke, the exhaust gases exit the cylinders and are directed toward a turbine, since this is a turbocharged engine. These exhaust gases spin the turbine at an insane speed, up to 125,000 revolutions per minute at full throttle. But there's a problem. The turbo can sometimes create too much boost pressure. To control that, engineers use a small valve called a wastegate, which releases excess exhaust gases, preventing overboosting. The turbine is connected to a shaft, and on the other end of that shaft is another turbine, called a compressor. While the exhaust turbine spins from exhaust gases, the compressor pulls in fresh air from the intake duct above the driver's head. There's a catch. The compressed air gets very hot, and hot air isn't ideal for combustion, so it needs to be cooled down before entering the engine. F1 cars use two types of intercoolers to cool this air. Air-to-air intercooler. Here, the compressed air passes through a radiator in the side pod, where cool outside air flows across it, reducing its temperature before it enters the engine. Water-to-air intercooler. A more compact and efficient system used by many F1 teams. Here, the compressed air is cooled by circulating cold water through a heat exchanger. The water then moves to a separate radiator to release the absorbed heat. After cooling, the air enters the plenum, a sealed chamber that balances the air pressure before distributing it to each cylinder through intake runners, also called trumpets. Then, the usual 4-stroke cycle continues: power stroke, exhaust, turbine spin, and the loop repeats. This V6 turbo engine alone produces about 850 horsepower. But is that enough for Formula One? Absolutely not. To reach the magic number of 1,000 horsepower, the car relies on its hybrid electric system. F1 cars, since 2014, use two generators, the MG-UK and the MG-UH, which together form the Energy Recovery System ERS. Motor generator unit, kinetic. This unit is connected to the engine's crankshaft. When the driver applies the brakes, it works as a generator, converting the car's kinetic energy into electrical energy and storing it in the battery. Again, when the driver accelerates and needs extra power, the MG-UK switches roles. It acts as a motor and uses the stored electricity to help spin the crankshaft, giving the car a boost in performance alongside the internal combustion engine. Motor generator unit, heat. As mentioned earlier, the split turbo setup works well, but a lot of energy in the exhaust gases would normally go to waste. The MG-UH fixes that. It's attached to the turbocharger's shaft, where it acts as a generator, converting rotational energy from the turbo into electrical energy. But it's not just a generator. The MG-UH can also use stored electrical energy to spin the turbo directly. This helps eliminate turbo lag, keeping the turbocharger at optimal speed even when exhaust gas flow is low. Together, these two systems add around 150 extra horsepower, taking the total power output close to 1,000 horsepower. But from 2026, things are changing completely. The power split will be 50-50, meaning 50% from the engine and 50% from electricity. That's around 540 horsepower from the V6 and another 470 horsepower from the hybrid system. To achieve this, F1 cars will use larger batteries, and the MG-UK will be able to recover much more energy, up to 8.5 megajoules per lap, compared to just 2 megajoules before. But what about the MGU-H, the system that recovered energy from the turbocharger? Well, it's gone. Now, all the energy recovery will depend solely on kinetic energy generated during braking. This means the hybrid system is no longer just an add-on, it's essential. If the battery is damaged or fails, the machine instantly loses half of its total power. But what about overtake? Previously, F1 cars used to have a drag reduction system, which is now scrapped and going with a... In normal driving conditions, the hybrid battery provides about 350 kilowatt of power. However, this power gradually decreases after 290 km per hour and completely cuts off at 345 km per hour. But when a car is within 1 second of another, like in an overtaking scenario, the driver can activate manual override mode. When MOM is active, the car can deploy an extra 0.5 megajoule of energy, maintaining a constant 350 kilowatt of boost up to 337 km per hour, before gradually tapering off to zero at 355 km per hour. In short, manual override mode gives drivers a temporary burst of electric power to help them overtake, replacing the old drag reduction system. You never know when your rival might unleash that extra power. So, the 2026 power units aren't just an upgrade, they're a complete transformation. The focus shifts from pure engine power to smart energy recovery and efficiency. Half the car's power now comes from electricity, marking a massive step toward the future of sustainable racing. Because in Formula One, evolution never stops.